this example. I have this example. I have this cylinder. You see the cylinder? This is a cylinder. What type of cylinder is that cylinder?
Single action.
Double port, single action.
Is single action, excuse me, is double action single shaft. Double action because you have an input here and output here.
Okay.
And you have one shaft. That's correct? Okay. Suppose that you have that cylinder. And this is the cylinder, for example, for the garage door in your boat. And the system use 800 psi. This is the pressure of the system. Remember that it is a hydraulic system. The pressure is constant. Okay, my friends? The pressure is constant. And the pressure of the system is 800 psi. I have a question. That cylinder produce the same force in both directions?
No.
No.
No. In what direction the force is bigger? Force number 1 or force number 2?
Going this way, going back.
That force number 1 is bigger than force number 2?
Yes.
Yes. Okay, we are going to demonstrate what is the force number 1. Suppose that the area in the big side is 5 square inches and the area of the rod is 1 square inch. We are going to calculate the force number 1. The force number 1 is equal to the pressure divided by the area number 1. What is the area number 1?
It's 5 inches.
No, this is the area, the big area, and this is I am trying to calculate the force number 1. I need use this area.
Okay.
How much is that area?
1 meter. 1 inch.
Is 5 inches minus 1, the area of the rod. Yes or not?
Oh,
yes.
Yeah.
Okay. In that case, is 800 divided by 4.
4.
This is 200 pounds. Ready? And now we are going to calculate the force number 2. The force number 2 is 800 divided by the area number 2. This is the area number 2. How much is that?
5.
It's 5 square inches. The big area, no? Sorry. The big area is 5 square inches. How much is that?
160.
Excuse me, 150?
No, 160.
160 pounds. Which force is bigger?
The 4.
The force number 1. Yeah. This type of actuator, one force is bigger than the other one. How can I solve that situation if I want an actuator with an equal force in both directions?
Here we go.
What type of actuator? For example, I need for the power steering in my boat. I need an actuator that produce the same force in both directions. What type of cylinder is recommended in that case?
Double action.
You say double action. Okay, let me check. You say double action or double shaft?
Double shaft, double action.
Double shaft.
Double action.
Double shaft. Double action. No?
Yeah.
In that case, you have the same area in both
sides.
In both sides, and the force number 1
is equal to the force number 2.
The force number 2. Yes or not?
Yes, sir.
All right, great. Excellent. Difficult, my friends?
No.
Okay, in the future, you are ready to do that situation. Okay, other important job is the consolidation of all the hydraulic systems in one central hydraulic unit. You remember I explained that situation in previous chapters, in previous videos in the laboratory. You remember?
Yeah.
For example, suppose that you have this situation. You have the garage door. The garage door require 150 psi. with a flow of 5 gallons per minute. The Pasarela, 120 PSI and 4 gallons. The David, 100 PSI with 3 gallons per minute. And the bow thruster, 130 PSI with 2 gallons per minute. That's correct, my friends?
Yeah.
Okay. The question is, with that information, how can I need calculate the motor, the capacity of the motor in kilowatts. This is the $1 million question. And I need calculate the breaker for that electric motor, correct? And I need calculate the capacity of the pump, the capacity of the pump in PSI and gallons per minute, because I am going to use a central hydraulic unit with one electric motor, with the breaker and the pump. All right, we are going to calculate the pump. How much is the capacity of the big pump that I need?
500 PSI.
Let me check. It's 130, 250, 350, 500. Okay, 500 PSI. And how much is the total flow?
14 gallons a minute.
14, no?
Yeah, 14.
Okay. In the pressure, it's good idea select a pump of 500 PSI.
Bigger than
No,
that.
you need a little bit more.
The recommendation is 500 plus
Plus 20%.
20%. How you added 20%?
600.
How you added 20%, guys?
0.2 or 2.
You multiply times 1.2. All right?
Yep.
500 times 1.2, probably 600, something like that.
600.
Okay. And the flow is okay, 15 gallons per minute. All right? You round it up. That's correct. This is the pump that you need is 600 PSI. And the flow is 15 gallons per minute. And now we are going to calculate the electric motor. I am going to calculate the electric motor. You remember the formula that you have in your book, that the formula that you have in your book in the page 42. In the page 42, you have the formula. The horsepower
Equals PSI times GPM divided by 1714.
1714, correct. Okay, I have the total pressure is 600 times the flow, 15, and divided by 1714. All right, this is the horsepower, but I need the kilowatts. How you convert?
For every horsepower, it's 746 watts.
Correct. Every horsepower is 746 watts. And how much is that amount of horsepower? 600 times 15 divided by 1714. Can you help to me? It's 5.2 horsepower, no?
Yes.
Would you
Okay.
round? Would you round that or no?
Yeah. In this case,
It
okay.
should be like 5.3. No?
5.3. Yeah, that's correct. 5.3. And if this is 5.3, how much watts are here? 5.3 times 746.
9,084.
Excuse me?
9,084.2.
Okay, you need 10 kilowatts. Yes or not? That's correct?
Yep.
Yes.
Okay, pay attention. You need a motor of 10 kilowatts. and you need a pump of 600 psi, 15 gallons per minute. And now we are going to calculate the breaker. When you select AC motors, what is better? A motor single phase or a motor double phase?
Double phase.
Why double phase or three phase is better?
Less consumptions in amp.
Less consumption of amps. Okay, suppose that my boat is, the voltage is 240, 60 hertz. Okay, what about the power? Power is equal voltage times intensity. The power that I need is 10 kilowatts. 10 kilowatts should be equal to the voltage, 240, times the intensity. Then the intensity is 10,000 because it's 10 kilowatts divided by 240. How much is that?
41.6.
41.6 amps. What do you prefer, a breaker of 40 amps or a breaker of 50 amps?
Breaker of 50.
50.
Okay, in that case, you approximate to a breaker of 50 amps. You like it, my friends?